Good morning, good evening, good afternoon to all the EO 120 students. This is Scott Sexton, your Hillbilly Professor again, and we're going to be going over some services. We're going to be looking in the NFPA 2023. We're going to talk about uh, electrical services. So, everybody, while you get a chance, go ahead and break out your code book and let's look at Article 230. Article 230, it's going to cover your stuff coming into the house, okay, or the into your building. That is your incoming service, conductors, disconnect, uh, service breakers, service disconnect means, service overskirt protection, and your branch circuits. Branch circuits are actually covered past this, past in 210, 225, 215, 225. So, here again, we're looking in the NEC code book and we're feeding this little diagram. And you see this a lot in some of these in the front of these. And the 230 section specifically calls this out. It shows it. If you look into motors in the 430 section, it kind of gives you this little breakdown. So how do I read this? Okay. How do I transfer this information into what does this mean in the real world? Well, this information, let's look at this from this aspect as this stick one line diagram. You got your overhead pole service conductors, the service head, which is your weather head, service entrance conductors, the service equipment, your grounding bonding first means of disconnect, service equipment disconnect means, and the service overskirt protection. Okay, well that doesn't mean a lot to me in the real world because I've not dealt with this book or been out there. So what does this really mean? Here's an example, okay, of an electrical service coming into your home. So here's a utility pole. Talk about this. That's the last pole, the incoming underground, the incoming overhead or underground service main. This is all overhead on the left. This is all underground on the right. We go back here. Now this is our weatherhead. Okay. Let's go back to the NFP link itself. Well, now we're talking about the overhead at the last pole, overhead service conductors. We're talking about these conductors right here. Okay, and then of course that's your meter. Here is your service panel on the inside and just a very short distance between the meter and the service panel itself. This is an example of the full system if you had a generator, okay, on a commercial building. You have utility pole, transformer, your service point. Number two is service conductors, okay. Number three is another piece of service equipment. First means disconnect. Then you have some other equipment in here. Number five, that's all your feeder conductors. Number six is a transfer switch. This right here would be your home, your house panel itself, generator, and if the power utility goes down, it swaps over to generator feed. So this is kind of like an example of what this really looks like. So Article 230, okay, it covers the installation requirements for service conductors and equipment. Service equipment, service point. What it does not do, NEC doesn't have to do with any of this. It does not. This part right here, this is all utility. This is all determined by utility under different standards and codes. So as electricians, we're dealing with from here back that way. Basically everything from this service head coming in. So the pipe going down, the meter, the first means of disconnect, the panel on the inside, the wires going in. And that's what Article 230 covers on this. So let's go in and let's take a look at this thing, okay? So 230.2, right off the bat, it says the number of service, a building, it's number of services. A building or other structure served shall be supplied by only one service unless permitted in 230 232.2a through D. There is a couple of exceptions in here, and it talks about the underground sets of number one or larger during the same location connected to service supply. So the special conditions. So all right, what does this mean? Here we are again. I've got this reference and I can't really visualize it. This is what they're talking about. I own a large enough building, okay, I can have two separate services on a building, okay, as long as because of why I'm under it falls under the 232.e A, B, C, D. Okay, where a building or structure is supplied by more than one service, any combination of branch circuits, feeders, and services or permanent plaques directory shall be installed at each service disconnect location denoting their services, feeders, branch service, circuit supplying the structure to each building. Okay, we can put two different types of services on a building. I can put a 480 volt service and I can put a 240 volt or 208 volt service. And I can have two separate meters. Okay, in here that says we can do this. And that would be for the billing regulation, as far as you have some equipment that will give you that you need to have on a separate meter for a different billing rate. And another part of your equipment can be on a different rate. And it's a way to be able to save money for companies. Okay. So we're going down through here and we're looking at the scope right off the bat, number of services. It goes on to say that you can't supply another building, okay, in through another building. One building or another structure cannot be supplied through another. So basically, if you have a service on one end of the building and you're trying to supply another end to another building, you can't go through the building. You have to go around. It cannot be going through it. And it reads, service conductor supplying a building or other structure shall not pass through the interior of another building or structure. Basically means that you got to get them conductors and that feeder away from any buildings. Now let's see what this says. 230.6 is considered outside of a building. Conductors shall be considered outside of a building or other structure under the following conditions. Where installed under not less than 2 inches of concrete beneath the building or other structure. See, they just told us we couldn't do that. Can't be supplied through another building. But it's talking about passing through the interior of another building. So we've got to be, I can do that if it's under 2 inches of concrete beneath the building, or where it's installed within a building or other structure in a right of way that's encased in concrete or brick not less than 2 inches thick. If it's installed in a vault that meets the particular construction of Article 250 or 450, when it's installed in conduit and under not less than 18 inches of dirt beneath the building or structure, and where installed in rigid metal conduit or IMC used to accommodate the clearance requirements 230-24 and routed directly through an eave, but not the wall of a building. Other conductors, circuit conductors, and other service conductors shall not be installed in the same raceway or cable handhold or any underground box as the service conductors. Well, what does that mean? Well, in the end, what that basically means is you can't mix for 230.7, you can't mix your load side in with your line side. Line side being this would be your service entrance conductors. They're coming through. This is the meter base. You can come through here with multiple sets of conductors as long as it's part of the service. But if it were a branch circuit or another service, a system that was not the service wires themselves, you couldn't mix them. Okay? Can't do that. And that's talking about 230.7. Service conductors are permitted to be in enclosures with other conductors. Okay, in the enclosures, but they're not permitted to be in the same raceway. Only service conductors can be in the raceway itself. Goes to talk about a raceway seal. Okay, clearances on buildings. It talks about this is where you go to be able to find out how far you need to be. This, for example, A, and we have the A, B, and C. Service conductors installed as open conductors or multi-conductor cable without an overall outer jacket shall have a clearance of not less than 3 feet from windows that are designed to be opened, doors, porches, balconies, ladders, chairs, fire escapes, and other similar locations. They're talking about the triplex that is normally dropping out to your homes. That's the type of clearance that they've got to have. Now, if this was service entrance rated SEER cable, be a little bit different. Vertical clearances, okay? Vertical clearance of a spinal span above 3 feet measured horizontally from platforms, projections, and other surfaces that will permit personal contact shall be maintained in accordance with 230.24. And that references us back to 230.24, where we have some 10-foot references and 12 and 15-foot, depending on the classification of what these are. If you're in a building, you know that it says that the electrical service entrance to buildings at the lowest point from the drip loop from the building, electrical entrance and above areas and sidewalks accessible to pedestrians is a 10-foot measurement from final grade to the surface. And it goes on. This is where you go to be able to find some of those specific key code questions, because I could very well at some point in my teaching ask everyone, what is the clearance for service entrance conductors over public streets, alleys, or roads? And you'd need to know that you have to come back to 230.24 to be able to get your vertical clearances. Vegetation as support. Huh. Well, vegetation would mean trees and shrubs. You can't use those as support to build those overhead conductors. So if you've got a service pole somewhere, you're 100, 200 feet back to where your service power is, you can't use trees. You got to set poles, or you got to go underground. And that right there it tells us where we cannot, what it is we shall not be used. And that's where we're looking at right here at 230. Now, 230.10. Now, this is all just under part one. Okay. We go back up here to the services themselves. We were just looking on part one. Okay. Just before we really get into this. Okay. If we go to part two, it's talking about the overhead service conductors. There's that 230.24 reference for clearances. So if you get a problem and you can't remember something, you go back to this 230, and it kind of gives you a hint. Hey, if I need overhead service clearances and questions about that, I go to 230.24. Or if it's an underground service and I need to know how deep it needs to be and how it's protected, you go to 230.32. So this is kind of one of those things that you need to look at this, but people really don't see it. It's a roadmap or a cheat sheet built into it to be able to go, hey, I'm thinking about this portable service. I need to go look here for it. So let's look at part two real quickly. Part two, talk about the insulation and coverings. It says, hey, it's got to be covered. You can't have bare wires. Okay. The exception is a grounded conductor of a multi-conductor cable shall be bare. Okay, so that would be just a grounded conductor. The grounded conductor of a multi-conductor cable shall be permitted to be bare. So that they're talking about the neutral in a service entrance rated conductor. You open them up, look at it on the side of your house. You've got your gray wire that comes up, and if you look in it, it's neutral. It's bare. That has no jacket on it. And that's where the action says you can get by with that. Okay, where that's legal. Talking about the size and ampacity, that means that they got to have a sufficient ampacity to carry the current for the load. It's calculated in accordance with parts 2 and 4 of Article 220. And they also got to have mechanical strength. Okay, adequate. Minimum size shall not be less than 8 copper or number 6 aluminum. And there's an exception here. The grounded conductor, shall not be less than the minimum size required by 25024. So a lot of people will still, and I don't do it anymore, but they'll derate their neutral. They'll take the neutral to the smaller size. I don't normally do that just because of the problems it could potentially give you for harmonics. If it's calling for three odds, I go ahead and put the fourth wire as a 3 odd and do all my calculations based on that. Here we are, 23024A, talking about clearances. Okay, we're talking about overhead clearances, and it's referencing 23028 for other informational supports. We got 3 or 4 different exceptions here, so be aware that these exceptions, okay, do play in. Got to know them here. Vertical clearances for overhead service conductors. Here's this reference here: 10 foot, 12, 15, 18, and 24. Okay, so we're talking about that's under 230-24 clearances. And if you look up here, well, 230-24, it's telling the clearances. So if I know how high this thing needs to be over a road or over whatever, this is where I go to look. Oh, there we go. Now let's look at the point of attachment. Okay, what is a point of attachment? Point of attachment for overhead conductors to a building or other structure shall provide a minimum of clearances as specified in 239 and 230-24. In no case shall this be attachment of less than 10 feet above finished grade. But what is a point of attachment? These particular point attachments that we're talking about on this are going to be, this right here is what we're looking at. That's your point of attachment. On this particular one, it's attaching to a vertical mast. Okay. On some of these things, it could very well be a knob connection. So let's just continue on here, shall we? 230-28, the service mast as a support. That's basically talking about this point here again, the service mast itself. And that tells us where this becomes legal whenever we're attaching it, as long as we're applying by this. Okay. Only a power service drop or overhead service conductor shall be permitted to be attached to the service mast. Service mast used for the support of service drop or overhead service conductors shall be installed according to 230-28A and B. Okay, so the mast has got to be of adequate strength and braced with guy wires or braces to withstand the strain of the service drop overhead conductors. And hubs intended for use with the conduits shall serve as mast and shall be identified for use with service entrance equipment. So listen, when they're talking about this, they're talking about force and they're talking about wind. You wouldn't believe how much force is actually being put on that mast on your house or that point of attachment, whether it be a knob on the side of your building or that service mast. As that triplex is swinging in the wind, it's yanking and yanking against things. You get weather down south a lot. You get a lot of ice. You get ice buildup up here, but specifically down there, every year, come the first of winter, we would get major service calls to go out and rebuild services, because ice would build up and rip these things out. Okay, and that was why, as a rule back in where I come from, your service mast in Oklahoma is requirement to be a 2-inch rigid. And once they made that requirement, the amount of services that started that got ripped out every year diminished. There were still calls where they had to repair this point here, or a worn wire that comes across it. And they would be doing that because they would have to do that because either this wire would break or one of these wires would get ripped off because of the ice. Okay. So, there is a real world reason for every one of these codes that you read. And, again, it's pretty dry reading sometimes. I'm trying to make it a little more exciting with some of these pictures that aren't working out real well today, but, we're trying. So let's look at some underground services. Let's look at the requirements. So that's going to be part three. So the installation itself, okay? The underground service conductor shall be insulated for the applied voltage, and it's got some exceptions in here that you need to take a look at. The wiring methods, what's available. Underground service conductors shall be installed in accordance with applications of this code, RMC, IMC, all these different items here. All right, so let's put this in our mind. What is an underground service? What are we talking about? What are we looking at? Well, this is what we're looking at when it comes to underground services. Where you have utility coming in, this is a typical connection to a home in a residential area that doesn't have overhead service lines locally to the house. So you'll have the little green boxes out by the road. These guys will serve probably 3 to 5 houses. And out of there, they'll come over and have a conduit going underground up to the first service point, which would be your meter itself. So instead of going overhead and have the riser and all those items, it all goes underground. And if we continue over to the right just a little bit, what we'll be able to find is here's another example of an overhead service versus our underground service that we're just looking at. Of course, we're looking at the underground section on here. Let's go back up here and take a look. Talk about the wiring methods. Again, the size and capacity is going to be roughly the same as what we covered before. So here's the one, 23032, 23032, protection against damage. Okay. This underground service conductors shall be protected against damage in accordance with 305. Service conductors in a building and other structures shall be installed in accordance with 236 and protected by raceway wiring methods in 23043. So this one code references back to 3 other codes. Instead of them saying, hey, you need to do this, they're saying, oh, okay, we already said this here, here, and here. Reference back and look back there. Okay. They talk about the splice conductors that kind of closed out. It says service conductors shall be admitted to splice or tapped in accordance with 1, 2, 3, 4, 5 separate different codes. All right, team, this is going to close out today's lecture. We'll pick it up on Wednesday for part 4 on the service centers conductors.